We're given this mathematical expression that consists of three complex numbers. 2j minus 1, which is in rectangular form, 2 times the quantity j plus 1, which is also in rectangular form, and e to the j 30 degrees, which is in polar form. We want to simplify this expression to provide it as a single number in complex exponential form. Now what we're going to have is a multiplication by 2j minus 1 times e to the j 30th divided by 2 times j plus 1. Multiplication and division are generally most easily done in polar coordinates. So let's take these two numbers that are in rectangular coordinates and convert them to polar coordinates. So 2j minus 1 becomes in polar coordinates a number with a magnitude, which is the square of the real part, -1, plus the square of the imaginary part, 2, and it has an angle, e to the j, inverse tangent of the imaginary part, which is 2, over the real part, which is -1. Now if I just take -2, plug it into my calculator, and take the arctangent of that, I'll get something that I'm not sure is actually right. What I have to do is check the quadrant that that's in. So real, imaginary. The real part is -1, the imaginary part is 2, so the number is going to be up in here, it'll be in that quadrant, and I'll need a phase angle that has something between 90 and 180 degrees of phase. So simplifying the magnitude, -1 squared is 1, 2 squared is 4, so this becomes square root of 5, e to the j, and taking that arctangent, it's 116.6 degrees. Now let's convert this number to polar form. So 2 times j plus 1 is 2 times j plus 2. That has a magnitude that's the square root of the real part squared, 2 squared, plus the imaginary part squared, which is also 2 squared. E to the j, inverse tangent of the imaginary part is 2, the real part is 2. So this is arctangent of 1. If we check the quadrant, the real part's 2, the imaginary part's 2, our numbers in the first quadrant, and our phase angle should turn out to be 45 degrees. So this becomes 2 times the square root of 2, e to the j, 45 degrees. Now let's plug these numbers into this expression. So 2j minus 1 becomes square root of 5, e to the j, 116.6 degrees, divided by 2 times the quantity j plus 1 became 2 square root of 2 e to the j 45 degrees. And finally we have a number that has a magnitude of 1, e to the j 30 degrees. So we have a division and a multiplication involved. Let's first do this division between this and this. So dividing two complex numbers in polar coordinates, I divide the magnitudes, so that's just square root of 5 over 2 times the square root of 2, and I subtract this phase from this phase. That becomes e to the j, 71.6 degrees. Now that gets multiplied by this number, which is just 1 e to the j 30 degrees. So multiplying the magnitudes, I get this times 1, which is just square root of 5 over 2 square root of 2, e to the j. To get the phase, I add this phase to this one. It becomes 101.6 degrees. There's my final answer.